AnyLogic is a multi-method simulation modeling tool developed by the AnyLogic Company, former XJ Technologies. It supports agent-based, discrete event, and system dynamics simulation methodologies. AnyLogic PLE edition is available for free for self-educational and educational purposes. History of AnyLogic. In the beginning of the 1990s, there was a big interest in the mathematical approach to modeling and simulation of parallel processes. This approach may be applied to the analysis of correctness of parallel and distributed programs. The Distributed Computer Network (DCN) research group at St. Petersburg Technical University developed such a software system for the analysis of program correctness. The new tool was named COVERS, Concurrent Verification and Simulation. This system allowed graphical modeling notation for system structure and behavior. The tool was applied for the research granted by Hewlett-Packard. In 1998, the success of this research inspired the DCN laboratory to organize a company with a mission to develop a new-age simulation software. The emphasis in the development was placed on applied methods, simulation, performance analysis, behavior of stochastic systems, optimization and visualization. New software released in 2000 was based on the latest advantages of information technologies, an object-oriented approach, elements of the UML standard, the use of Java, a modern GUI, etc. The tool was named AnyLogic because it supported all three well-known modeling approaches: system dynamics, discrete event simulation, agent-based modeling, plus any combination of these approaches within a single model. The first version of AnyLogic was AnyLogic 4. Because the numbering continues the numbering of COVERS 3.0. A big step was taken in 2003. When AnyLogic 5 was released, it was focused on business simulation in the following domains: market and competition, healthcare, manufacturing, supply chain, logistics, retail, business processes, social and ecosystem dynamics, defense, project and asset management, IT infrastructure, pedestrian dynamics and traffic simulation, aerospace, photovoltaics. AnyLogic 7 was released in 2014, being the biggest release for 7 years. It featured many significant updates aimed at simplifying model building, including enhanced support for multi-method modeling, decreased need for coding, renewed libraries, and other usability improvements. AnyLogic 7.1, also released in 2014, included the new GIS implementation in the software. In addition to shapefile-based maps, AnyLogic started to support tile maps from free online providers, including OpenStreetMap. 2015 marked the release of AnyLogic 7.2 with the built-in database and the Fluid library. The free Personal Lee Reining Edition, PLE, was also introduced in 2015. The new Road Traffic Library was introduced in 2016 with AnyLogic 7.3. The platform for AnyLogic 7 model development environment is Eclipse. AnyLogic is a cross-platform simulation software as far as it works on Windows, Mac OS and Linux. AnyLogic and Java. AnyLogic includes a graphical modeling language and also allows the user to extend simulation models with Java code. The Java nature of AnyLogic lends itself to custom model extensions via Java coding as well as the creation of Java applets which can be opened with any standard browser. These applets make AnyLogic models very easy to share or place on websites. In addition to Java applets, the professional version allows for the creation of Java runtime applications which can be distributed to users. These pure Java applications can be a base for decision support tools. Multi-method simulation modeling. AnyLogic models can be based on any of the main simulation modeling paradigms. Discrete event are process-centric. D. Systems dynamics. SD. And agent-based. AB. System dynamics and discrete event are traditional simulation approaches. Agent-based is a newer one. Technically, system dynamics approach deals mostly with continuous processes, whereas discrete event, by which we mean all descendants of GPSS, also known as process-centric simulation approach, and agent-based models work mostly in discrete time, i.e., jump from one event to another. System dynamics and discrete event simulation historically have been taught at universities to very different groups of students, namely management and economy, industrial and operation research engineers. As a result, there are two distinct practitioners communities that never talk to each other. Agent-based modeling until recently has been mostly a purely academic topic. However, the increasing demand for global business optimization caused leading modelers looking at combined approaches to gain a deeper insight into complex interdependent processes having very different natures. How modeling approaches correspond to the abstraction levels. System dynamics dealing with aggregates is obviously used at the highest abstraction level. Discrete event modeling is used at low to middle abstraction. As for agent-based modeling, this technology is used across all abstraction levels. An agent may model objects of very diverse nature and scale. At the physical level, agents may be e.g., pedestrians or cars or robots. At the middle level, customers. At the highest level, competing companies. AnyLogic allows the modeler to combine these simulation approaches within the same model. There is no fixed hierarchy. So, as an example, one could create a model of the package shipping industry where carriers are modeled as agents, reacting independently, whereas the inner workings of their transport and infrastructure networks could be modeled with discrete event simulation. Similarly, one can model consumers as agents whose aggregate behavior feed a system's dynamics model, capturing flows such as revenues or costs which do not need to be tied to individual agents. This mixed language approach is directly applicable to a wide variety of complex modeling problems that may be modeled via any one approach, albeit with compromises. Features. Simulation language. The AnyLogic simulation language consists of following items. Stock and flow diagrams are used for system dynamics modeling. State charts are used mostly in agent-based modeling to define agent behavior. They are also often used in discrete event modeling, e.g., to simulate machine failure. Action charts are used to define algorithms. They may be used in discrete event modeling, e.g., for call routing, or in agent-based modeling, e.g., for agent decision logic. Process flow charts are the basic construction used to define process in discrete event modeling. Looking at this flowchart, you may see why discrete event style is often called process-centric. The language also includes low-level modeling constructions, variables, equations, parameters, events, etc., presentation shapes, lines, polylines, ovals, etc., analysis facilities, datasets, histograms, plots, connectivity tools, standard images, and experiments frameworks. AnyLogic libraries. AnyLogic includes the following standard libraries. The Process Modeling Library is designed to support a simulation in manufacturing, supply chain, logistics and healthcare areas. Using the Process Modeling Library objects, you can model real-world systems in terms of entities, transactions, customers, products, parts, vehicles, etc. Processes. Sequences of operations typically involving queues, delays, resource utilization, and resources. The processes are specified in the form of flowcharts. The Process Modeling Library is a successor of the Enterprise Library from AnyLogic 6, which is also available in AnyLogic 7. The Pedestrian Library is dedicated to simulating pedestrian flows in a physical environment. It allows you to create models of pedestrian-intensive buildings, like subway stations, securities checks, etc., or streets. Large numbers of pedestrians. Models support statistics collection on pedestrian density in different areas. This ensures acceptable performance of service points with a hypothetical load, estimates lengths of stay in specific areas, and detects potential problems with interior geometry, such as the effect of adding too many obstacles, and other applications. In models created with the Pedestrian Library, pedestrians move in continuous space, reacting to different kinds of obstacles, walls, different kinds of areas, as well as other pedestrians. Pedestrians are simulated as interacting agents with complex behavior, but the AnyLogic Pedestrian Library provides a higher-level interface for faster creation of pedestrian models in the style of flowcharts. The Rail Library supports modeling, simulating, and visualizing operations of a rail yard of any complexity and scale. The rail yard models can be combined with discrete event or agent-based models related to loading and unloading, resource allocation, maintenance, business processes, and other transportation activities. The Fluid Library allows the user to model storage and transfer of fluids, bulk goods, or large amounts of discrete items, which are not desirable to model as separate objects. The library includes blocks such as tank, pipeline, valve, and objects for routing, merging, and diverging the flow. To improve model execution speed, the Fluid Library uses a linear programming solver. The library is designed to improve AnyLogic use in manufacturing, oil, gas, and mining industries. The user can simulate oil pipes and tanks, or coal conveyors, and production processes where liquids or bulk materials are involved. For example, in concrete manufacturing, the Road Traffic Library allows users to simulate vehicle traffic on roads. The library supports detailed, physical-level modeling of vehicle movement. Each vehicle represents an agent that can have its own behavioral patterns inside. The library allows users to simulate vehicle movement on roads, taking into account driving regulations, traffic lights, pedestrian crossings, priorities at junctions, parking lots, and public transport movements. The library is suitable for modeling highway traffic, street traffic, on-site transportation at manufacturing sites, or any other systems with vehicles, roads, and lanes. A special traffic density tool is included to help analyze road network loads. Besides these standard libraries, users can create their own ones and distribute them. Model animation. AnyLogic supports interactive 2D and 3D animation. AnyLogic allows users to import CAD drawings as DXF files, and then visualize models on top of them. This feature can be used for animating processes inside objects like factories, warehouses, hospitals, etc. This functionality is mostly used in discrete event, process-based models in manufacturing, healthcare, civil engineering, and construction. AnyLogic software also supports 3D animation and includes a collection of ready-to-use 3D objects for animation related to different industries, including buildings, road, rail, maritime, transport, energy, warehouse, hospital, equipment, airport-related items, supermarket-related items, cranes, and other objects. Models can include custom UI for users to configure experiments and change input data. Geospatial models. GIS integration. AnyLogic models can use maps as a layout, which is often required by supply chains, logistics, and transportation industries. AnyLogic software supports the traditional shapefile-based map standard, SHP by Esri. In addition, AnyLogic supports tile maps from free online providers, including OpenStreetMap. Tile maps allow the modeler to use map data in models and to automatically create geospatial routes for agents. The main tile map features in AnyLogic include: the model can access all of the data stored along with online-based maps, cities, regions, road networks, and objects, hospitals, schools, bus stops, etc. Agents can be placed in specified points on the map and moved along existing roads or routes. Users can create the required elements inside the model using the built-in search model integration with other IT infrastructure. An AnyLogic model can be exported as a Java application that can be run separately or integrated with other software. As an option, an exported AnyLogic model can be built into other pieces of software and work as an additional module to ERP, MRP, and TMS systems. Another typical use is integration of an AnyLogic model with text, MS Excel, or MS Access files and databases, MS SQL, MySQL, Oracle, etc. Also, AnyLogic models include their own databases based on HSQLDB. Free educational version. Since 2015, AnyLogic Personal Learning Edition, PLE, is available for free for the purposes of education and self-education. The PLE license is perpetual, but created models are limited in size. For public research in educational institutions, users can obtain a discounted university researcher license, which does not limit model size and has a lot of the functionality of a professional license. AnyLogistics supply chain optimization software. AnyLogic does not include a specific library for supply chain simulation, as the AnyLogic Company converted its development efforts for this domain in a separate software tool, AnyLogistics. This spin-off product was introduced in 2014 as AnyLogic Logistics Network Manager and was renamed AnyLogistics in 2015. AnyLogistics is based on the AnyLogic engine, GIS, and the new industry-oriented GUI. It also includes algorithms and techniques specific for supply chain design and optimization. AnyLogistics is fully integrated with AnyLogic. For instance, AnyLogic can be used for customization of objects inside AnyLogistics, including warehouses, production sites, suppliers, inventory, sourcing, and transportation policies. See also: comparison of agent-based modeling software, list of computer simulation software, list of discrete event simulation software, computer simulation. Further reading. Law. Avril M. 2006. Simulation Modeling and Analysis with Expert Fit Software. McGraw-Hill Science. ISBN 978-0-07-329441-4. Banks, Jerry. John Carson. Barry Nelson. David Nickel. 2004. Discrete Event System Simulation 4th edition. Prentice Hall. ISBN 978-0-13-144679-3. Sterman, John D. 2000. Business Dynamics. Systems Thinking and Modeling for a Complex World. McGraw-Hill. ISBN 0-07-231135-5. Official website. AnyLogic overview at AnyLogic.com.